afternoon, everyone. My name is Alan, and I will be serving as the Master of Ceremony as well as the moderator for today's event. The agenda for today's event is as follows: the first opening, the second event introduction and introduction of the speaker, the three material presentation by the speaker, the fourth closing. We now move on to the second agenda. Today seminar is the main understanding application of derivative. This seminar focus on the application of derivative to determine increasing function, decreasing function, and stationary points. Through this seminar, we hope participants can gain a better understanding of how derivatives are used to analyze the behavior of function. For today's seminar, we are pleased to have our speaker, Rara. She will present the application of derivative in identifying increasing and decreasing function as well as stationary points. I would like to invite Rara to deliver the presentation. We now move on to the third agenda.
Good afternoon. I would like to thank to Alan as the Master of Ceremony and moderator for the introduction and the opportunity. Today, I will discuss the application of derivative to determine increasing function, decreasing function, and stationary point. I hope this session will be useful and easy to understand for all. So derivative represent the rate of change of a function and are used to determine increasing function, decreasing function, and stationary point. So this is the graph. When the function is increasing when x is greater than a, decreasing when x is less than a, and has a stationary point when x equals a. So, if the function f of x is given, then if f prime x is greater than 0, then the function f is increasing. If f prime x is less than 0, then the function f is decreasing. If f prime x equals 0, then the function f is stationary. So I have an example. So this is the example. Given f of x equals 112x to the power of 4 minus 56x to the power of 3 plus 2x squared plus 7x plus 4. Find the increasing function, decreasing function, and stationary point. So this is the solution step. I have 3 steps. So the first step, we find the first derivative. So the question f of x equals 112x to the power of 4 minus 56x to the power of 3 plus 2x squared plus 7x plus 4. So we find the first derivative. So f prime of x equals 412x cubed minus 156x squared plus 4x plus 7. And the second derivative is f double prime of x equals 12 x squared minus 36x plus 4 become x squared minus 5x plus 4. So the step 2, find the stationary point So we substitute the value of the second derivative. So set f double prime of x equals to 0. So x squared minus 5x plus 4 equals 0. So we factoring become x minus 4 times x minus 1 equals 0. We factoring give x minus 4 times x minus 1 equals 0. So x equals 4 or x equals 1. And then when x equals 4, we substitute x equals 4 into the function. So the result is 32, or the first stationary point is 4,32. So when x equals 1, we substitute x equals 1, and the result from f of 1 equals 49/4, or the second stationary point, 1,49/4. So the stationary point are 4,32 and 4,49/4. So the step 3, we determine the increasing and decreasing interval. So we find function increasing f double prime x greater than 0. So we substitute the result, it becomes x squared minus 5x plus 4 greater than 0. And we factoring become x minus 4 times x minus 1 greater than 0. And then we find function decreasing f double prime x less than 0. So the next, we test the interval. So this is the interval. We draw a number line, then we write the numbers 1 and 4. It can be seen that. So the final conclusion, so the function is increasing when x less than 1 and when x is greater than 4. Then the function is decreasing when x is between 1 and 4. So the conclusion, derivatives are an important concept in calculus that represent the rate of change of a function with respect to its variable. In their application, derivatives are used to determine the behavior of a function, such as increasing interval, decreasing interval, and stationary point. By finding the first derivative and analyzing its sign, we can identify where the function increases or decreases. Furthermore, stationary points can be found by setting the derivative equal to 0 and substituting the value into the original function. Interval testing and the use of a number line help to clearly illustrate the behavior of the function on each interval. Therefore, the application of derivative is very useful for understanding the characteristic or function graphs and for solving various mathematical and real-world problems. I hope you understand. So I am back to the moderator.
Ladies and gentlemen, this brings us to the end for today's seminar. We would like to thank you, our speaker Lara, for the valuable insight and all participation for your attention and support. On behalf of the moderator, I am apologize for any shortcomings during the event. Finally, we officially close the seminar. Thank you for watching and see you at our next time.